All right, so what we're going to do right now, demonstration on how to plot star temperature and luminosity. This is known as a Hertzsprung-Russell diagram, and this is how scientists classify stars. So what I'm going to show you over here is how to do this graph. I'm going to give you 3 data points, and it'll be a good way to understand how we're going to do this for the rest of the class. There are 2 things we need to pay attention for this graph. One is it's very different than any graph you've seen before. So for example, while we still have our x and y axis, we have all of our labels. Typically, our graphs go up by even intervals. So 5, 10, 15, 20. This graph does not do that. Rather, its intervals jump unevenly. Another thing we need to notice is 0, 0 does not belong on this graph. Typically, the graphs we see in the past, they have a 0, 0 data point due to where the lines intersect. In this case, 0 is actually on the right side for temperature, and 0 is on the left side for luminosity or brightness. So this has to do with the way in which stars are classified in terms of temperature, is that stars on the right side of the graph are cooler than on the left side of the graph. And actually, as you start to shade this tomorrow, you'll see that actual progressive change from cool to hot. So I'm going to show you 3 different data points. I'm going to start off with the Aldebaran star. And I want to start off with this star because it gives us a good data point that we're used to. So for example, this star has a temperature of 4,000 Celsius, and it has a luminosity, meaning it has a brightness of 100 in comparison to our sun. So it's 100 times brighter than our sun. So in this case, I would start off at 4,000. I would draw up. I would make my data point just like it would on any other type of graph, and then I would label it. In this case, I'm just doing ALD because I'm going to do shorthand. The next data point I'm going to show you is our sun. Now our sun is going to be a little different. Our sun has a temperature of roughly 6,000 Celsius. Now we can see that that number isn't actually on the graph. Rather, it's going to fall somewhere between 8 and 4. So what I'm going to do, make a little dash right here. This will represent my 6,000, which you can feel free to write in on your own if you feel necessary. And I'm going to simply go up to 1. Right there, data point, and I'm going to label it. So you'll notice right away, right? Some data points will have an intersection of lines. Some data points will simply be on one line. Now the last one I'm going to do is going to be a little bit different altogether. I'm going to do what is known as Vega. So Vega has a temperature of 9,700. So that's going to fall roughly here. Remember, these aren't perfect data points. They're doing the best we can. So Vega, roughly 9,700, right there. And Vega has a luminosity of 60. You'll notice that that does not happen here at all. Rather, 60 will be between 50 and 100. So what I will do is I will simply draw up to actually in the middle of a box. And that's something we need to understand is okay, is you can actually plot data points in the middle of a box. We'll label this as Vega. And this is the example of the 3 different ways in which you can plot data points on this graph. 1, intersection, intersection.